Hi, welcome to the video for Algebra 1 on arithmetic sequences. We're going to be looking at these different sequences and doing a couple things with them today. You're going to watch this video, copy these notes down on your paper exactly how I'm doing them. Feel free to add extra notes if you'd like to. But first, let's start by going through the directions. So it says, determine if the sequence is arithmetic. If it is, do the following. 1, write the next term. 2, write the common difference. And 3, write the explicit rule. So there's a bunch of vocabulary I'm seeing in here that we need to start thinking about, or we won't be able to do what it's asking. So first thing I saw was arithmetic. I need to remember what an arithmetic sequence is. And if I look back in my ISN at our definition, it says a series of numbers that are changing from one to the next by either adding or subtracting a constant number or a fixed number. So adding or subtracting a fixed number. So the same thing over and over again. So that is actually, that number that I'm talking about is the common difference here. So that's part of what we need to find if it's arithmetic. If it's doing something other than adding or subtracting the same number over and over again, then it's not arithmetic and I don't have to go any farther. So first I have to determine if it's arithmetic, because then I can do these next steps. Some of those next steps I won't be able to do. I might be able to do the next term if it's not arithmetic, but I won't be able to find a common difference because there won't be one. I won't be able to write an explicit rule because the only one we have right now is arithmetic. All right, so first, looking at the first example here, 9, 19, 29, 39. Is there something that's being added or subtracted every single time to get the next term? I know that from 9 to 19 I can add 10. And then from 19 to 29, I can add 10 again. And from 29 to 39, I can add 10 again. So I can see the pattern is adding 10. So that means it is arithmetic. It's adding or subtracting a fixed number. It's adding 10 every single time. So that means I'm able to write my next term. If I add 10 again, the next term would be 39 plus 10, which is 49. So my next term is 49. Then I've got to find my common difference. Well, I already found that. I knew I had to find that in order to be able to find the next term. So my common difference, which the variable we use is d, is equal to 10. And then I need to write the explicit rule. So the other piece of information we need to know for writing the explicit rule is the A1. A1 is the first term in the sequence. So the very first number in our sequence is 9. So that is my A1. When I go to write the formula for my explicit rule, we start with a sub n equals d parentheses n minus 1 plus a sub 1. So let's talk about those pieces. Some of these pieces are just notation, like the a sub 1, that means the term that I want, whatever term that is, the 10th term, the 12th term, the 100th term. So this a sub n is going to stay in front, and then the equals will stay. But what I know is the d value is 10, so I can substitute that 10 right in that d spot there. But then I'm going to copy the n minus 1, and I know my a1 value is 9, so I'm going to add 9 at the end. So if you look, you can see, I color-coded it for you, that the only things I entered into the explicit rule were the d value and the a1 value. So now this looks exactly like the work we were doing on simplifying expressions. I can distribute my 10, I can combine any like terms. The a sub n on the left side and the equals are just going to stay in every row of work that I do, and I'm going to simplify this side. So I'm going to start with a sub n equals, then I've got 10 times n, which is 10n, then I've got 10 times negative 1, which is negative 10, then I'm going to bring down this positive 9. I'm going to combine my like terms, so I've got a sub n equals 10, and negative 10 plus 9 is negative 1. So our explicit rule is a sub n equals 10n minus 1. So if I wanted to find any number down the sequence, I could say, let's find the 75th term. I'm going to do 10 times 75 minus 1. So this is a general rule that will help us find any term in the sequence. Okay, number 2. Again, let's go back to determine if it's arithmetic. I notice that the numbers are getting bigger, but they're actually negative, so that really means they're getting smaller. How much are they getting smaller by? What's happening each time? Because they're getting smaller, I know it's subtraction. And if I look from 14 to 17, it's going down by 3 because it's getting more and more negative. So this could be a little tricky if negatives are tricky for you. Remember, the bigger the number with a negative sign in front of it, it's actually the smaller number. So -3, -3, and again -3. So that is arithmetic because this time I'm subtracting a fixed number, and that number is -3. If I want to find the next term, I'm going to subtract 3 again, and that's going to be -26. If I want to find my common difference, well, I already know that, it's -3. This time, because I'm subtracting, I'm going to make sure the negative goes in front of the 3. And then my first term in the sequence is this term up front here, -14. So my A1 is -14. I'm going to go ahead and substitute that in to my formula. Let me write the formula down first. A sub n equals d parentheses n minus 1 plus a sub 1. So I'm going to substitute in my d value and my a sub 1 value. So a sub n equals -3 parentheses n minus 1, close my parentheses, plus -14. If you wanted to write a -14, that's fine. They're the same thing, so I can actually change that to be just subtract 14. Adding a -14 and subtracting 14 are the same. Again, I'm going to distribute my -3 through. So let me bring down a sub n equals -3 times n is -3n. -3 times -1. I remember negative times a negative is a positive. 3 times 1 is 3. And then bring down this -14. I'm going to combine my like terms. A sub n equals -3n. Positive 3 minus 14 will be -11. That is our explicit rule. -3n minus 11. We've got one more example to do together. Again, let's go back to the beginning. Determine if the sequence is arithmetic. So if I look from 18 to 10, that's subtracting 8. Then I look from 10 to 6, that is subtracting 4. Then I look from 6 to 2, that's subtracting 2. I see a pattern. It's getting half each time. The number that I'm subtracting is half each time. My next one, I probably would subtract 1. But that's not a fixed number, so this is not arithmetic. So since it's not arithmetic, I'm not able to continue doing the rest of what it's asking. I could find the next term. If the pattern, in fact, was to subtract 1, my next term would be 3. But I can't find a common difference or write an explicit rule, so I'm done. I just wrote not arithmetic. I'm going to box my answer, and that is it. So if you have any questions, feel free to ask me during class. If you're all set and this makes sense to you, you're ready to move on to practice 1. So come see me for that in class, and you'll be able to work independently on that and hopefully have some success. Thank you for watching. Feel free to pause, rewind, anything that you need to do to make sure you understand the material.